So this is the homework for tonight. You don't have to write the problems down. You can just pause the video and do these 4 problems in your notebook, and you're allowed to use a calculator. So go ahead, pause the video, and then complete these 4 problems in your notebook. When you're done with that, take a look at page 11 of your packet. Again, pause the video and look at the notes on page 11. The top portion and this middle portion are just notes about average rate of change versus average value of a function. Average rate of change is just the change of y over change of x. I have a physics interpretation, the change in distance over the change in time. Graphically, it's the slope of the secant line. Here's how you come up with the units, right? You take the units of the numerator, let's say if that's feet, and then the time is in seconds, so it'll be feet per second. And if b is really close to a, then average rate of change is used to approximate the derivative. We've done that before. Average value is the new stuff. Here's the integral, and this is the geometric interpretation. It's the height of the rectangle with the same area, and the units. So the one on the quiz, there was a problem on the quiz about the object suspended from a spring. It was this one. Actually, I don't want to show the quiz problem, but the point I'm trying to make is the units of the average value are the same as the units of the integrand. So the one on the quiz, it was like the height of the spring, and let's say the height of the spring, and it was from 0 to 2. Let's say the height of the spring is represented by feet. When you do the average value formula, your answer is also in feet. That's what this part's saying. Okay, so let's do an example of average acceleration where we use the average rate of change of velocity. So it's average rate of change of velocity, not in velocity, of velocity. So we're looking for average acceleration, and we're doing the change of y over change of x. It's a slope between 2 points on the velocity function. It would be v of 15 minus v of 9 divided by 15 minus 9, and we can't find an answer because I never gave you the velocity function. I actually gave you no function, no equation. But we can just talk about how to do it. We can talk about the units. So velocity, I'm going to make up units, will be feet per second, and then this is time, it's seconds, which makes sense because we're finding the average acceleration, which will be feet per second squared. So this makes sense because it would be feet per second squared. Let's talk about this. Method 2 of doing the same thing, average acceleration. This is the average value of the acceleration function. That's one way to interpret the average acceleration. So one way to interpret average acceleration is the average, because acceleration, right, isn't acceleration the rate of change for velocity? That's what acceleration is. It's the rate of change of velocity. So one way to think of it is taking the velocity function and doing change of y or change of x. The other way of thinking about it is taking the average value of acceleration. So it's just an integral of acceleration, a of t dt, over the interval, which in this case is 9 to 15. And then let's not forget to multiply by the difference, which is just 6. Both of them, guys and girls, will give you the same answer. So when do you use method 1? When do you use method 2? It depends on the problem. If the problem gave you the acceleration function, that's what you should do. If the problem did not give you the acceleration function, but the problem gave you v of t, you should use method 1. If the problem gave you a of t, you should use method 2. Again, I wish I had an example with specific equations to show you they both give you the same answer. Let's confirm with the units, right? I said on top the units are the same as the units of the integrand when you're doing the average value formula. So if the integrand is acceleration, you know the units here are going to be feet per second squared, because those are the units. It's going to be the average acceleration between this time. And look, the units are the same, so I'm hoping that convinces you that both of them would produce the same answer. It's just a different way of doing it because it's based on what function you were given. So let's do an example together. Let's do number 3. This is a rate. The rate at which water sprayed on a field of vegetables is given by this. This is the rate. This is the rate that water is being sprayed. And look, we're T's in minutes and ROT's in gallons per minute. So this is a rate. It's gallons per minute. During the time interval 0 to 4, what is the average rate of water flow in gallons per minute? So we can think of average of the rate of water flow. So let's think about, did they give me a function that represents the rate of water flow? Because if they did, then I'm just going to do the average value formula on the function. So because they gave me, this is the rate of water flow, this is the rate at which water is sprayed on a field. So this is R of T right here. Since they gave me that function and they want me to find the average of this function. And when I find the average of this function, it's going to be the integral of that 1 plus 5t cubed dt from 0 to 4. And I have them multiplied by 1/4. And again, let's confirm, this is in gallons per minute. And I said that when you use the average value formula, your answer is going to be the same, gallons per minute, which is what they're asking. Go grab a calculator to get this answer, and then I want you to do number 2 and number 4.